That's right, it is a sunny day coming at you November 10th, 2014, the 45th anniversary of Sesame Street. And to help celebrate this, let's make some feed. Something that only Oscar the Grouch would want to eat. All right, so here's the problem we got. Number 6. Morningstar is a company that sells agricultural products to farmers in several states. All right, so as you read through this, you're going to realize that this average of U.S. citizens consumes almost 70 pounds of poultry per year. That's pretty amazing. But you're making an order for a special local chicken farmer for 8,000 pounds of feed. Now what the farmer wants is that the feed contain 20% corn, 15% grain, and 15% of minerals. And so you as Morningstar who are going to make this feed want to know, how do we fill this order at a minimum cost? All right. So read through the problem, hit pause if you need to about all the information given. And then think about and try it on your own. Can you write out the linear program? What are our variables? What's our objective function? And what are our constraints? Okay, all right, so let's see what we're doing. So here's the issue we have. So to kind of help us see what it is we're doing. So here we have in our factory, we have this machine with feed 1. All right, and it pours down this little chute right there. We have here feed 2. This is like wicked awesome art right now. Feed 3. And feed 4. And we're going to pour it into this new container right here of what our customer wants. And what they want is they want a feed that is 8,000 pounds, and it's going to contain 20% corn, 15% grain, and 15% minerals. Sounds quite healthy. All right, so the question is, what are our variables? What do we get to choose? Well, as Morningstar, we own feed 1, 2, 3, 4. So these are big vats full of our feed with these characteristics. So feed 1 has 30% corn, 10% grain, 20% minerals, and then 40% of some other stuff. All right, and we have feed 2 has these characteristics, feed 3 and feed 4. So what we get to do is we get to turn on the machine for feed 1, 2, 3, 4. It's going to dump it into this new feed that the customer wants. All right, so what we want is let X1 be the pounds of feed 1. X2 be the pounds of feed 2. X3 are the pounds of feed 3. X4 are the pounds of feed 4. So that's what we get to choose. We don't get to choose anything with the minerals that are inside of feed 1, 2, 3, or 4. Those are characteristics of them. All we get to choose is we turn the machine on for feed 1 and how many pounds do we put into our machine. So that there is defining our variables. Now we want to think about how do we minimize the cost of this order. All right. Well, if X1 is the number of pounds of feed 1 we use, that's going to cost us 25 cents per pound. So our objective is to minimize our cost function, which is 25 cents for pound 1. It's going to come at 30 cents for feed 2, plus 32 cents for feed 3, and 15 cents for feed 4. So that's our objective function. Now let's think of our constraints. Okay, so there's really 2 issues of constraints here. So the 70 pounds of poultry per year per person is quite interesting, but doesn't play into this problem at all. What does play is this 8,000 pounds and the requirements within. So let's think of the 8,000 pound because that's the easiest one to think about first. So our constraints are such that, well, if X1 is the pounds of feed 1, then if I add up all of these, that's the total poundage of new feed. So X1 plus X2 plus X3 plus X4 has to equal 8,000 pounds. We have to create a feed that is 8,000 pounds. Now the next constraint we want to think about is, of this 8,000 pounds, we want 20% of that to be corn. Well, if x1 units is pounds, then let's convert our constraint not to a percent, but to actual pound amount. All right, so we want this to be less than or equal, not less than, but the amount of feed we use to be at least 8,000 pounds times 20% is our right-hand side variable. And this is for corn. Well, how many pounds of corn come into our feed? Well, if I use feed 1, for every pound of feed 1 I use, 30% of that is corn. For every pound of feed 2, 0.05 is corn, plus 0.2 x3 plus 0.1 x4. So if I use 10 pounds of each, that means 3 pounds are going to be from feed 1 of corn, a half a pound from feed 2, 2 pounds from feed 3, and 1 pound from feed 4, so 6.5 total pounds. Well, I need to use more poundage of each feed to be able to get to this requirement. The next is grains, and it's going to be very similar. 0.1 of x1 plus 0.3 of x2 plus 0.15 x3 plus 0.1 x4 is greater or equal to 8,000 times 15%. And lastly, we're going to have 0.20 x1 plus 0.2 x2 plus 0.2 x3 plus 0.3 x4 has to be at least 15% of 8,000. And there we have our linear program. And now we just got to turn to Excel and see how we insert that in. And now it's going to definitely be a sunny day.